What's up guys, welcome back. So today I wanted to look at z-score tables and how to use them. So let's get into it. Now, think back to the z-scores. What we're kind of looking at, the z-scores tell us how many standard deviations you are from the mean. And we know that from our empirical rule that, for example, if you're one standard deviation above the mean, that must mean you are, or there are 84% of people below you. Let's say you're doing height. So in other words, for example, if you're 182 centimeters, there are 84% of people that are shorter than you. Okay, so it's very, very handy when we have the empirical rule and also the z-scores of 0, 1, 2, and 3, or negative 0, minus 1, 2, and 3. But the problem comes because you're not always going to get z-scores which are exactly whole numbers. That's where the z-score table comes in. So on the left, you can see there's a z-score table. It looks pretty complicated and looks very messy. This is just a snippet. In reality, it's much, much bigger. But let me just walk you through how you would use it. So the question says, what percentage of people are shorter than you if you're 179 centimeters tall? Well, before we actually do anything, we need to work out what the z-score is for someone that height. So you can see here, if I just put in 179, it's probably going to be around this mark here. So the z-score should be somewhere between 0 and 1. So z is equal to 179 minus the mean, which is 175. That's in the middle. And what's the standard deviation? Well, remember the standard deviation is just the distance, the actual number distance from each z-score. So in this case, what's it going up by? It's going up by 7 centimeters. So just work that out in the calculator. So 179 minus 175 over 7. So we get a z-score of 0.57. So as expected, somewhere between 0 and 1. All right, so what we do after this is we actually go look for this number in the z-score table. So on the left-hand side, you've got the first decimal place, as you can see, going from -2 to 1. And on this row there, you've got 2 decimal place. So what are we looking for? We're looking for 0.57. So I'm going to come down here, 0.5, go across all the way till I hit 0.7. So my number there I'm looking for is, let's not cross it out, 0.715. Okay, so what does that mean? What this is saying is, what the z-score table tells us is 0.7157 as a percentage times 100 is 71.57%. Okay, so what that is telling us is there are, in this population, if you're 179 centimeters tall, there are going to be 71.57 people shorter than you. Okay, because the table here, the z-score table always shows towards the left. So just remember that, that's super important. The z-score table is always going to show towards the left. So to answer this question, there are going to be 71.75 people shorter than you. Okay. Now we can also ask the opposite question. What's the percentage of people taller than you? All we need to do is remember everything under the curve is 100%. So the percentage of people taller than you is going to be 100% minus 71.57. So what's that? 100 minus 71.57. So that's going to be 28.43% of people that are taller than you. Okay? Let's have a look at the next question. Calculate the z-scores for the student's performance in both subjects, then using a standard z table, find the percentage of students that scored less than this student. So, very similar exercise. Let's just do this question. So, let's just set it up as a table to make it easier for myself. So here we've got maths, here we've got English. What's the z-score for maths? 88 minus 85 over 3.5. So 88 minus 85 over 3.5. So that gives me a z-score of 0.86, let's say. For English, 85 minus 92 over 4.5. 85 minus 92 over 4.5. So that's minus 1.56, let's say. And we want to know the proportion or the percentage of students less than these results. Okay, so sometimes it helps just to visualize. Here we've got maths. If this is 0, this is 0.86. If this is English, we've got minus 1.56. Okay, so I will get up the z-score table. All right, so here's the z-score table. And first of all, I'm gonna look for 0.86. So first of all, these are all negative values. So let's go all the way to 0.8. And I'm gonna come across here. So 0.8's here, 0.06 is here. So 0.86 is gonna be that number there. So 0.8, let me highlight that. 0.51. Now I'm just going to convert that to a percentage now. So it's 80.51%. So in other words, there are 80% of people, or 80.51% of people that performed worse than this student in maths. Okay, let's look at English. So you've got minus 1.56. So I'm going to look for minus. This is all positive. So minus 1.5 is here. Zoom out a bit. Minus 1.5 is here. 0.06. So where do they align? That number there. So 0.0594 times 100. So that's going to be 5.94%. So in other words, there are only 5.94% of people that performed worse than this person in English. So in other words, they did pretty terribly. Okay. All right. So I hope this video helped. If you have any questions, let me know down below. Otherwise, I'll see you in the next one. Peace.